So you just go from there. All right, let's just go ahead and tackle this last question. So they didn't ask, to solve it on an interval or all the solutions. So I am just going to, let's just solve all the solutions. So if I had tangent of theta equals -1, all right, so based on the unit circle, we can say when is tangent of theta equal to -1? Well, that's going to be here and here. So those angles, we can say theta is going to equal a 3 pi over 4. Jeez. I hate now like mistyping. Actually, now I realize I like mistype so many times. So this is going to be a 3 pi over 4. And Anthony, you're pushing it. Yeah, all right. I'll graph that, Anthony. I can do it real quick. Same thing I did last night on the live stream. But again, you have 3 pi over 4, which is that angle. And then you have theta equals 5 pi over 4. Okay, that would be that angle right there. So if we want to write these as all solutions, we could say theta equals 3 pi over 4 plus pi n. Because if you have this angle, you add pi, it's going to take you that answer, and you keep on adding pi infinite many times. Now, what do we do over here? Well, the interesting thing with this case is we're going to really solve it the exact same way. The only problem is instead of solving for theta, it's now going to be x over 2 plus pi over 4 is equal to 3 pi over 4 plus pi n, right? If this was just tangent of theta equals -1, we would have, theta, or what's inside the parentheses, right? You could put parentheses here. Whatever's inside the parentheses equal to 3 pi over 4 plus pi n. So what we're doing is just taking, all right, instead of writing theta, we're going to write pi halves plus pi over 4 equals 3 pi over 4 plus pi n, which is the same solution. Now we're basically just going to solve for x. So we'll subtract a pi over 4. That's going to leave me with a 2 pi over 4, which is pi halves, plus pi n. And now you can just multiply by 2 times everything. So x is going to equal pi plus 2 pi n. And if you had pi plus 2 pi n, I believe